All right, this is the big to-do about radians. So what happens is we just went through and measured in degrees. It's nice to have those. We had 0 and 30, and we counted by 30s. We had 45s, and we counted by those, and 60 and 90, and so on. And those are all degree angles. But there's another measure. So if I complete that first half circle, 120, those degrees are 135, and so we can zoom in a little here, 150 and 180. Those are all your degree measures. In the box, what I'm going to put in is the equivalent, what's called a radian measure. Now, radian measure is based on a very simple idea. Now, 0 in radians is still radians. So we've got degrees on the inner circle, and then what we have are radians on the outer circle. It's another way of measuring an angle that's based on 180 degrees being pi. Now, it sounds kind of random, but it's actually very mathematically savvy and helpful that it's equal to pi. And that's developed from somewhere, so it's not something that's random as much as it seems. But play with that idea. If you can just think 180 is pi, the rest all falls into place. It's just that if 180 is pi, we think of, all right, if I were halfway to pi, I'd be straight up, right? Well, that's exactly what we call it. We don't call it pi, we call it pi divided by 2 because it's halfway to pi. So radians are always a measure of how close am I to pi, with respect to, so am I halfway there? I can be a quarter of the way to pi. So if you look at it, let me break this up into various things. I'm going to do quarters here now. So if I break up, this is 145, 90, 135. If I look at those blue markings on there, those 45 degree, those are fourths. I just made that half circle on top into fourths, therefore little sectors on top of there. That means each one of those is a fourth of pi, like a fourth of the way to pi. So the first one we actually call it pi over 4. And so I'm going to delete this back a little bit. So we actually call this pi over 4. And up top, the 90 degree, now we already called it pi over 2, but you can actually call it, if you want, 2 pi over 4s. So when you write something like this, that's called iterative form. I'm actually saying the first one was 1 pi over 4, and now that circled one there is 2 pi over 4s. The next one will be 3 pi over 4s, because you're counting how many pi over 4s that you're working with. And then, of course, then it'll be 4 pi over 4, and 4 pi over 4 is, what you'll notice is the ones that are already labeled, they simplify to the one in red next to it. So 2 pi over 4 in the middle there simplifies to pi over 2. 3 pi over 4 doesn't simplify, so it stands, and then 4 pi over 4 simplifies to just pi. But knowing that pi is 180, then all the rest of these are just some statement about how much, well, it's a fourth of the way to pi, pi over 4, and then there is pi over 2 pi over 4. If I count by pi over 4, is 1 pi over 4 wedge, 2 pi over 4 wedge, 3 pi over 4 wedges, and 4 pi over 4 wedges. You can keep going by 45s. There's 5 pi over 4, would be the one facing down here. 6 pi over 4 straight down. So you're just counting those pi over 4 wedges. That's what radians is to count by some multiple of pi, which is 180 degrees. 7 pi over 4 as you make your way around. Nice. And then finally we get back to the original 8 pi over 4. Now 8 pi over 4 simplifies to 2 pi. That's actually something, if you think of 180 as pi, then all the way around to 360 is actually 2 pi around. Okay, that's me count by pi over 4 because I think it's an easy one to notice, the fourth of the way to pi. Now that's where all the other measures in radians come from as well. You just have to figure out what fraction of pi we're talking about. So I'm going to actually delete a lot of this. I'm just going to clear all this off so you can get kind of a clean slate. And what I'll do is put the pi back in there. And we'll just develop the rest of those. We just did our pi over 4s. I'll leave those in there in that blue color, but around it we'll build some of the others. So let's do pi over 4 here. Got it. I'm not going to do the 2 pi over 4. I am going to do the 3 pi over 4, because if it simplifies to something else, I'm going to leave it. I know pi is at 180. I'm going to skip that one, which was 4 pi over 4. It's good to remember that. And then 5 pi over 4. I'm just counting 45 degree wedges. 6 pi over 4 is straight down, and then 7 pi over 4 is what we had here. Those are my blue ones. Now the next size I like to count by, 30 degrees. Kind of nice. It fills in a lot of the blanks. Now 30 degrees, we already filled in here before. That is, if you know that pi is all the way over to 180. Okay, it's just a different way to measure. We know that 30 is it's a sixth of 180. 30 times 6 is 180. So it's 1/6 of the way there. So 30, the other way we think about it is it's not all the way to pi, it's a sixth of the way to pi. We call it pi over 6. So 30 degrees is pi over 6, a sixth of the way to pi. In that wedge size, I'm going to just kind of mark them along here. Those are the first two 30s, pi over 6, and then the second one here. We're going to call it 2 pi over 6 right now. Notice it simplifies, and we will simplify that. It simplifies to pi over 3. 3 pi over 6 is straight up. We already have pi over 2 there, so let's put that in. I'm going to call it 3 pi over 6 for now, just for fun. And I'll get out over to pi, and then I'll go back and simplify these a little bit. And then there's 4 pi over 6. It's kind of, you get to see the size of that wedge. Then 6 pi over 6, you skip the 45. Because it's actually this little gap in between here. The two little gaps there are 15 degrees between, the 30 and 45 and 60 and 45 degree sizes. But pi over 6, I'm sorry, what was it? 4 pi over 6 is the last one I did, and then I'm up to 5 pi over 6. And then 6 pi over 6 is at pi. So you notice 4 pi over 4 and 6 pi over 6 land you in the same place because those 4s and 6s cancel. It's also healthy to know that that's an easy way to help count along the way. Okay, so I'm going to put that pi back in there. But that's it. We did some pi over 6s. We'll keep going in a minute. But you'll notice the ones that simplify, they simplify down to the other size that we're going to count by here shortly. Like 2 pi over 6 will be pi over 3. I'll do that one next. 3 pi over 6 goes down to pi over 2, which we've already labeled. 4 pi over 6 will become 2 pi over 3, so I'm going to delete that till later. And then 5 pi over 6 doesn't simplify, and then we're good. So I'm just going to keep counting those pi over 6 increments. Remember, it was 6 pi over 6 was 180. 7 pi over 6 is the next one down. So just fill these in as you go. 7 pi over 6, whoops, got a little scratch in there. And then 8 pi over 6, which will simplify. That one right there is the same thing as 4 pi over 3, so I'm going to delete it and come back to it later. That was 8. 9 pi over 6 is straight down, but I got to, this one actually I got, if I do 9 pi over 6, I'm actually going to write it in there. Okay, 7, we had 8 pi over 6, 9 pi over 6. 9 pi over 6 simplifies down to, if you divide them both by 3, to 3 pi over 2. And if you think about it, well, that's another size that we're going to count by pi over 2's. So I'm going to rewrite that as 3 pi over 2. You realize that sounds like we're counting by a pi over 2 size. If you remember, pi over 2 is 90. It's 3 times pi over 2, or 3 90s to get down there. And then we make our way around. I'm still counting by pi over 6's. I had 7 pi over 6, 8, 9 pi over 6, 10 pi over 6. And that'll simplify to something 11 pi over 6. And then if we back up to 10 pi over 6, that's one that simplifies to 5 pi over 3. We'll get that in a minute. But that's the pi over 6. It's those 30-degree wedges I was just making my way around by 30s. So let's go around one more time. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6. Whoops, 6 pi over 6, I'm sorry, 8, 7 pi, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6, and then 12 pi over 6 is the same thing as 2 pi, which takes me all the way around. Those are the nice pi over 6 wedges. Now I'm going to do the pi over 3 size, and if you look at it, I'm just going to do them, I'm going to count through. Here's a pi over 3. It's 60 degrees. 60 degrees is a third of the way to pi. Here's 2/3 of the way to pi, and there's 3/3. So we count by those pi over 3 wedge sizes, and that means I'm going to do 1 pi over 3 here. Then the next wedge of that size is 2 pi over 3. 3 pi over 3 takes me to pi, and then 4 pi over 3. That wedge size is, it's kind of good to notice. It's way down here. 4 pi over 3. 5 pi over 3, so I got to make another 60-degree wedge. It's like remember you got to count by 2 30s, so notice there's 2 30s between every one of those 60s, so it's a bigger leap. So 4 pi over 3 is the last one I had, and then 5 pi over 3, and then 6 pi over 3 is the same thing as 2 pi. Gets us all the way around. It's the last one here. I could write it, but just notice they always simplify to 2 pi, and that's what we call going full around the circle. Okay, that's counting by radians. We got most of them. The only other one I want to put up there is just how do you count by others, like pi over 2. I'll put those in there as a nice black line here, but pi over 2 is 90 degrees. So your first pi over 2, 2 pi over 2's. So if I got 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2 back at 360. So you can count by pi over 2's, which is 90 degrees. So you start getting this equivalent size business, and you can actually do some other fractions as well, are important. But you end up realizing pi over 6 is the same thing as 30. It's a sixth of the way to 180 degrees, since it's a sixth of the way to pi. Pi over 4 is 45 degrees, because 45 degrees is a fourth of the way to 180, and pi is the same as 180. And pi over 3 is 60 degrees, because it's 1/3 of the way to pi, and then pi over 2 is 90 degrees. Those are the increments that I counted by, and I just have kind of multiples of them. 5 pi over 6, for instance, right here, is 5 30s. So it's 5 times 3 is 150 degrees, is its equivalent right there. So that's actually a way to go back and forth between them as well. So that's the intro to radians. Now, there is another piece to this that I want to bring up. So we'll just talk about how to convert back and forth from those. But your job is right now, if you haven't ever done this, I want you to go ahead and get a hold of a filled-in unit circle. And I ask it that you would actually Google the unit circle or some video related to it and try and find something that kind of gives you another perspective on it to add on to what we've already talked about. So your assignment is, I do have an online quick assignment that takes you through some of this as well, but I want you to kind of explore out there, get yourself into what the unit circle is. There's plenty of explorations out there, and that'll kind of set you up for Wednesday when we develop this further and start using it to do more evaluation stuff. So trig starts to get pretty quick. We'll do some basic graphs and evaluating and some simplifying stuff. So take care. See y'all on Wednesday.